Hello everyone, welcome to your chemistry classroom. I am Lawal Adetunde, your chemistry tutor. To our returning viewers, welcome back to your classroom. To our new viewers, welcome to the chemistry classroom. Please do well to press the subscribe button, turn on your notification button, press the like and share button and put your comments in the comment box. As we have all known that we are in the season of NECO 2025 and we have released a lot of videos on chemistry practical, physics practical, and likewise some other practicals, biology practicals, and we continue with our chemistry practical. A lot of videos have been released. This is another video that we are bringing to your screen. Especially this is question 1, quantitative analysis, titration. Now we have on the screen a question saying that based on the information and the contents that NECO gave to us, we have A is a solution of 0.100 mole per dm cube of hydrogen trioxynitrate 5, and we have B is a mixture of 8 grams of sodium trioxynitrate. B is a mixture of 8 grams of sodium triazocarbonate 4, that is Na2CO3, and sodium triazonitrate 5, that is NaNO3, in 1 dm of the solution, and we have our indicator there as methyl orange. This practical you are seeing on the screen, I have done it and it has been released in one of our video, in our previous video, but now is the time to do the calculation on it. So, procedure. When I did the practical, my theta value there was 26.10 centimeter cube. That is, I want to now do calculation, I want also solve questions based on this theta value, 26.10. Now let's read the procedure quickly, which I have done in the previous video. Rinse and fill the burette with solution A. As usual, we know that acid will be inside the burette, and using a pipette of 20 centimeter cube or 25 centimeter cube, I used 25 centimeter cube and I got my theta value 26.1 centimeter cube. All this procedure I did, they said add 2 to 3 drops of methyl orange and repeat the titration to obtain the concordant results. Now, because I told you I did the practical and I got 26.1, how will I present my information on my table? That is, I want to bring out my table of values. That's what I have to show you, right? Showing you how I'll present my theta value, which is 26.1, and to use it for my calculation. How will we go? Now, my theta, my rough value, I can put anything in my rough value. Let's say I'm using 45.0 minus maybe 3.0, and this one gives me 42.0. My rough, I'm not using it, so the value says the value there is not useful for me. Now, what I need, I want to get 26.10 here, and I want my initial to be 0.00. Definitely, I'm having 26.10 as my final for the first theta. For the second theta, now from where, now remember my burette is 50 centimeter cube. Definitely, I can't make this one to be my initial. I need to refill. In that situation, and I still want to maintain 26.10, I'm maybe to use, maybe I use 3.00. In that situation, I'll be having 29.10. So with this now, if you subtract my initial from final, I'll get this 26.1, same, I'll get it. So without wasting time, I'll go to my average theta value. Same, average theta value, which is first theta plus 7 theta, everything over 2. And which was my first theta? 26.10 plus 26.10, everything over 2. If I sum up this, this one will give me 52.20 over 2, and at the end of the day, I'll be having 26.10 centimeter cube. My theta value stands. That is, my VA stands. My theta value stands. I'm just writing this one there. Now, to start solving questions on what they give to us, I need to write out my parameters. So I will say, given, what are given parameters? They gave me in this parameter I'm writing here. On a normal day, it's supposed to be before my table. Because of that, I will now place it, because I want it to be before my table, I will place it. Okay, let me place it here. It doesn't affect. Let me place it here. Now, volume of pipettes. Volume of pipettes, I use 25.0 centimeter cube. In my indicator, I use methyl orange. All this one, just to gather mark, I use methyl orange. What information do I have from the question? They give me the molarity or the molar concentration of the acid. I can say my Ca, concentration of A in mole per dm³. They give it to me. That is my Ca as 0.100 mole per dm³. I have that one there. What again do you have as my, this is my Vb, this is my Vb, this is my Vb, and I have known my Va. I have known my Va, that's volume of acid, that's what I just got now. And this my Va is what? Is 26.10 centimeter cube. What information again do I need? If any information I will need now will not fall back to my, to my equation. Let me show you my equation, and from there I will continue. Now, looking at my equation, the number of mole of acid, that is 2, that of base 1, that is my Na. I will say my Na is 2, my Nb is 1. So all the information. So what I want to find right now from the first question says I should find the concentration of B in mole per dm³. That is, I want to find Cb. So in that situation, let me place it here. Now. Gradually, I'll be rubbing off my board so that I will have enough space. And I have our common formula CAVA over CBVB equals to NA over NB. What is my Ca? That is 0.100 times plus my Va. I'm using I got 26.10 over Cb, which is unknown, times what's my Vb? I'm using 25.00 equals to 2 over 1. When I cross multiply all this, I'll be having, because of time, I'll be having Cb equals 0.100 times 26.10 times 1 over 2 times 25.00, which means that my Cb, let's press my calculator because of time and accuracy. I have 0.1 times 26.1. I have 2.61. I have 2.61 over 50. So finally, Cb will give me, and this is the answer divided by 50. That one gives me 0.052 mole per dm³. Case closed. I have settled this now. It has gone. Now I want to find the mass of sodium carbonate in 250 cm³ of my D. That's what I'm going to find right now. So permit me to rub off my the upper side now, or I should take off this place. Maybe I should leave that place. Let me come to this place. Alright, now we pick up the next question that said that we should find the mass of sodium carbonate in 250 cm³ of this base that we just got now. Very simple question. We don't need to stress ourselves. We have seen that our molar concentration of the solution B is 0.052 mole per dm³. That shows that 0.052 moles in 1 per dm³, which means that the mole of this particular solution in this equation is what? Is 0.5 mole. Let me say, since 0.52 mole is in 1 dm³, definitely our mole is equals to 0.052 mole. And another we need to recall, mole is equals to mass over molar mass. Mass over molar mass. And what's the molar mass of sodium? What's the molar mass? The molar mass, permit me to divide this place. The molar mass of Na2CO3, that is 23 times 2 plus 12 plus 16, oxygen 16 times 3, or give us 106 gram per mole. In that situation, mass equals mole times molar mass. Please do well to put your comments in the comment box. If you have any question or you have any advice, we are together, please put it in comment box. Alright, mass equals to mole times molar mass. That is the mole here, 0.052 times 106. Let me press my calculator to settle that. Let me press my calculator to settle that. So we have 0.052 times 106. That will give us 5.51 gram, approximately to 2 decimal. That is the mass we have. That's the mass we have in what? That's the mass. That's the mass we have. Permit me to fill up this page so that I can now move to how much of it we are going to have in 20. Where's that question again? In 250 cm3. That is, it shows that we are having 5.51 gram in 1 dm3. That's the meaning. Remember, this 1 dm3 is the one that gave out to all this story here. So now I want to find the mass that will satisfy this 250 centimeter cube, which must be converted to decimeter cube, but we can still do it like this by saying 250 divided by 1000 equals to y, which means y equals to 5.51 times 250 over 1000, which means y equals, and please are able to judge that because of time. So here I got 1.3, that is 1.38 gram. That is 1.38 gram is the one that is in 250 cm3. That is, we have y equals to 1.38 gram in 250 into what? In 250 cm3. Or you can say 1.38 gram in 0.25 dm3. We are all saying the same thing. Anyone you want, you take it, and that will satisfy the answer to number 2. Now, answer to number 3 said that we should find the percentage purity. We don't need to disturb ourselves. You hear the word percentage purity. That is, your mission, your interest is purity. Purity over total. Remember, the solution B is a mixture. We show that carbonate, if you check in our equation, sodium carbonate is what we use. That is the one that is pure substance there. While the pure substance is the one that we use to complement with the sodium triazonitrate 5. Now, in that situation, we now say percentage purity is equal to mass of purity over the total mass of the sample. So that's what I want to do right now. I'm doing number 3 here. That is to find. I think let me use somewhere clearer so that we'll be enjoying it. Please don't skip, do well to watch your video, enjoy your video very well, so I'll be able to understand what we are doing here. So number 3 says that to find purity, percentage purity of Na2CO3. So which means that it will be, let me clear this place so that I have more space. Alright, I have mass of Na2CO3 over total mass of the sample. You may wonder that they gave us 8 grams. We have not used that 8 grams. Now it's time to use the 8 grams. Times total mass of sample times 100. Which means, what's the mass of sodium carbonate? We just got it right now. Where's that mass that we just got right now? That's the mass. 5.51 over 8 times 100. So let's do it together. 5.51 divided by 8 times 100 gives us 68.88%. That is the percentage by mass. That's percent of the purity. Now to find out of impurity, that one is very simple. You can do it in two ways. One, we can say a percentage that is 100 minus percentage of purity. Let me write it comprehensively. Where you will graph it very well. Maybe I should put it somewhere here. Let me put it somewhere here. I want us to enjoy it clearly. Number 4, percentage impurity. It can be done in two ways. I will show you two ways. The percentage impurity of Na, this now we can say is equals to 100 minus percentage purity of sodium carbonate. You are well on your own choice. 100 minus 68.88%. So that one will give me 100 minus 68.88. That will give me 31.12%. Or I can use the same way I use the formula here. Impurity is equals to mass of impure. We know our impure, that is mass of sodium triosnitrate 5 over total sample times 100%. Now, how can we get our mass of sodium nitrate? Remember, the mixture, the total is 8, and the mass of sodium carbonate is 5.51. We now say mass of sodium triosnitrate 5 will be 8 minus 5.51 gram, and that one will give us that is 8 gram minus 5.15 gram. Let's check that one. 8 minus 5.51, so that one gives us 2.49. So the mass of sodium nitrate is 2.49 grams. So you cannot relate it that same way, saying that percentage impurity will now become 2.49 over 8 times 100. I believe when we do it, we also get the same thing, but let's check, let's confirm that. So 2.49 times 100 times 100 divided by 8. So we have 31.12. 31.12. And this is how we satisfy all the questions given to us concerning the quantitative analysis. This should be the third or fourth video we are releasing on quantitative analysis. If we still get more information, we're still going to release even before the day of the examination. Please do well to turn on your notification button so that anytime we release our videos, you'll be the first person to see our video. Please do well to subscribe, press the like button, and put your comment in the comment box. Please put your comment in the comment box. Whether something is there that we have missed, put it there. Let's do it together. We are all here to learn. Alright, so we are satisfied the question given to us concerning the quantitative analysis. Also, do well to watch our videos on our qualitative analysis, or the SWOT analysis. I think we have released 2 or 3 videos on that. Please do well to watch. If you can't see it in our playlist, please check our videos on it on the same channel you are. Thank you so much, and I'll be waiting to see you in the next video. Bye for now.